Hey, come on. What if I told you that the word race card holds a secret? It's not just a word, it's a palindrome. And today we are unlocking the mystery of how to spot any palindrome in the wild. We are diving into the problem LeetCode number 125, and trust me, it's sneakier than it looks. Let's expose its secrets. You've probably seen plenty of them, words like mom, noon, or even this one. Basically, if you flip all the letters around the center, nothing changes. It still reads the same. But here is a fun twist. Even a sentence like this counts as a palindrome for this LeetCode problem. Why? Because we ignore casing, punctuation, and anything that's not a letter or a digit. Once you strip all that stuff out, you're left with a clean string that does read the same backwards. And what is the first idea that comes to mind? How to identify if the string is a palindrome or not? Let's just clean the string. Make it lowercase, keep only alphanumeric, reverse it, and check if the reverse version matches the original clean one. If they match, it's a palindrome. And here is how it could look in TypeScript. Feel free to pause the video and check it out. And how fast is this approach? First, we clean up the string, that's big O of n. Then we split the clean string into an array, reverse it, and join it back into string. That's 3 more ON operations. Finally, we compare the original and reverse strings. Comparing old characters takes another big O of n. So in total, we are doing around 5 passes over the string, 5 times big O of n. But in big O notation, we drop the constant, so the overall time complexity is just big O of n. And what about space complexity? Well, we're building a brand new string while filtering out and wanting characters. That's up to big O of n space. Then we reverse the string, which creates another copy, so that's another big O of n. Plus, during split and join, there is also a temporary array in memory, again up to an big O of n. So overall, we're using linear space or big O of n. And you know, this is the kind of solution you would ship in normal project without second thought. But at real interview, sometimes interviewers want to flex those algorithmic muscles a bit more. Sometimes they want a solution that doesn't use any extra space. So let's dive into a bit more fancy. What is a way to solve this? 2 pointers. Imagine we have our string. Instead of creating new strings, we'll just use 2 pointers. One at the very beginning and one at the very end. Once both left and right are pointing at a valid alphanumeric character, we convert them both to lowercase and then compare them. If they don't match, it's not a palindrome. We can stop right there and return false. But if they do match, great. We then move left 1 step forward and right 1 step backward and repeat the whole process. Our goal is to move left from the beginning towards the middle and right from the end towards the middle. But on every step we need to make sure that we skip all non-alphanumeric characters. If left is pointing at a space or a comma, we just move left forward until it finds a letter or number. Same goes for right. If it is on a non-alphanumeric character, we move it backward. We keep doing this until left meet with right in the middle. If they have met, congratulations! You've got yourself a valid palindrome. And now let's see how it looks in TypeScript. First, we define a small helper function is alphanumeric. It uses a simple regular expression to check if a character is a letter or a number and returns true or false. Nothing fancy, but super useful. Now for the main function is palindrome. We start by placing 2 pointers. Left points to the very first character, right points to the very last one. Then we fire up a while loop. It keeps going as long as the left less than right. Inside the loop, first we grab the characters at the left and right positions and lowercase them. Let's call them left char and right char. Now here comes the interesting part. If left char isn't alphanumeric, we skip it by moving left 1 step forward and continue to the next loop iteration. Same for right char. If it's not valid, we move right 1 step back and continue to the next loop iteration. Once both left char and right char are valid, we compare them. If they are not equal, we know right away the string is not a palindrome. Just return false and call it a day. If they are equal, we move both pointers inward and keep going. Finally, if the loop finishes without finding any mismatches, we return true. So now that we've got the logic down, let's talk about what really matters in the coding interview. How efficient is the thing? We're scanning the string once, moving the pointer towards the center. So the time complexity is big O of n, where n is the length of the string. And space? Here is where this solution really shines. We're not building new strings, not reversing anything, just using a couple of pointers and some variables to hold characters. So the space complexity is constant. Doesn't matter how big the input is, the memory usage stays tiny and interviewers loves it. And just like that, we've cracked the palindrome puzzle. You have now got the tools to tackle this classic problem in any scenario. If this video helped you, just drop a like. It really helps the channel grow. Ready for your next challenge? You're taking on a valid parenthesis next, a problem that hides really clever patterns you'll definitely want in your toolkit.